Welcome one, welcome all. If you haven't already, please chat in with a hello and where you're calling in from. My name is Betty Maya, and I am a communications associate with Dark Sky International, calling in from Moab, Utah, which is an international dark sky community. And I was looking at the Milky Way from my window last night and feel very lucky to have access to these night skies because of all of the work that everyone is doing around the world to raise the awareness of dark skies and make these changes happen. So yeah, happy to be here with you all today. And I just want to let y'all know this is our kind of first ever Nightscape Live event. We are renaming this. It's been Night Matters in the past, but we have been aligning all of our speakers with our awesome Nightscape publication. If you're not familiar, it's a quarterly magazine that Dark Sky releases, and we've actually won some awards for it. We just recently sent out our recent issue called Into the Blue, and it's all about the marine environment. So if you want to receive a printed edition of Nightscape in the future, you can join and become a Dark Sky member for at least $35 or above. So I'll pop a link in the chat. And no, Chris already did it. Thanks, Chris. So check that out if you want to learn more about Nightscape. It's such an awesome publication. Callie, do you have yours like right there with you? I know I have my, check out Callie and Natasha. Everyone's got theirs. Look at this beautiful magazine. You know you want one. So yes. Check out Nightscape, and this is Nightscape Live. So if you like what's in the Nightscape magazine, you're going to want to come to these events so you can really interact with the people who made that publication a reality. But before we get to our awesome speaker, Dr. Thomas Davies, I do have a few announcements of what's going on in the dark sky world. First and foremost, Capture the Dark, our premier astrophotography photo contest, is going on now, and we need more photos, especially of good lighting. So if we have a lot of different categories, there's 9 different categories within the photo contest. They're not all astrophotography Milky Way. We're looking for photos of bad lighting, of glare bombs. We all have those, right? Our neighbor whose light is shining into our window. We want photos of nocturnal or marine animals that are impacted by light pollution. And we want photos of good lighting, showing what good dark sky friendly lighting looks and feels like. So if you have any of these photos, please submit them. We have some really awesome prizes that you could win. So definitely check that out. And of course, we are all here today, probably because we learned about light pollution from somebody else, or we heard it on social media from an influencer that we're following. So if you have a person that is your dark sky hero, I know I have so many, and actually all of you are them, please submit them to our Dark Sky Awards program. And give them recognition for the incredible work that they're doing to protect the night. So please nominate your dark sky hero today. We just had our State of the Science document released, which is an annual publication that Dark Sky releases each year, where we go through all of the relevant scientific journal publications around artificial light at night and dark sky and consolidate them into one easy to read, accessible report. We just had a meeting about that last week with Dr. John Barentine, who compiles the report for us. So please check out the report. It's great to use in any presentation that you may have around light pollution. It's also a great leave behind with policymakers. And there's an awesome YouTube video recording of John's presentation about it, about how the whole document was put together and how you can use it in your advocacy work. So catch this recording and all of our other meetings on our YouTube channel, and Chris is going to pop that link in there as well. So thank you for sticking with me through the announcements. I can now get to our main event, which is Dr. Thomas Davies, who is an associate professor of marine conservation. Thomas has researched the ecological impacts of artificial light at night for more than a decade, specializing in how marine ecosystems are responding to the changing lightscapes of our oceans. He was principal investigator of the Natural Environment Research Council funded Artificial Light Impacts on Coastal Ecosystems, ALICE project from 2019 to 2024, and is a co-investigator on the Horizon Europe funded Aquatic Pollution from Light and Noise project. In 2023, he co-funded Go Allen with Dr. Tim Smith to provide a central resource for understanding and managing the impacts of light pollution in the sea. Thank you so much for being here with us today, Dr. Davies, and take it away.
Thank you very much. Let me just see if I can share my screen and bring up my presentation for you. That's you, that's me, and that should be full screen. Has everybody got that okay?
Perfect. It looks great.
Yeah. Okay, fantastic. Thank you very much. Like many of you, I am at home this evening. It's 7 o'clock in the evening here in the UK. It's a beautiful sunny evening here in the UK. Unfortunately, the only place where I seem to be able to find Wi-Fi signal is in front of my half-finished ensuite bathroom, which isn't the best backdrop in the world. So please do bear with me, but we'll make do for now. So I'm going to be talking to you about changing nightscapes in the ocean, a little bit about how they're impacting marine ecosystems and what we've been doing to try and create some more effective mitigation solutions towards limiting artificial light at night emissions into the sea. I've been working on marine light pollution for a very long time now, more than a decade. And when I first entered the field back in 2014, I published a paper where we postulated a number of impacts of artificial light at night on marine ecosystems, which have since been proven in the science to actually be the case. So things have moved on quite a way now. And I think that hopefully this presentation will tell that story, but it will also highlight how we are now in a space where we can really start to have an influence on policymakers to see if we can start to get better management of this issue. So much of this research has been funded by the Natural Environment Research Council, like you said, but also by Horizon Europe. And the Global Ocean Artificial Light at Night Network is a UN Ocean Decade endorsed program. Okay, so I wanted to start by talking about how important light is as a structuring force in our oceans. So when most kind of undergraduate students think about light in the ocean, they think about this diagram here. So this diagram basically it illustrates the major light zones of our oceans. So in the surface ocean, we've got this region called the photic zone, or the euphotic zone, some people call it. And it's basically where sunlight penetrates down to allow photosynthesis to occur. And then below that, we've got the twilight zone. So we don't get marine plants below this level, but we do get lots of animals that are still using natural light cues from the sun, from the moon, and from the stars, going all the way down, in some cases, down 200 meters and more. And then below that, we say, okay, so this is where appreciable light doesn't really penetrate to allow that to happen. And so that's called the midnight zone. And that's a fairly coarse resolution picture of light in the ocean. In actual fact, if you were to look into the photic zone, you would see much more fine scale structuring. So you'd see, for example, as you progress down a coral reef ecosystem, you see that the different coral species are structured, not just according to the intensity of the light as it changes down over, say, 50 meters depth, but also the spectral components of that light, so the color of that light as it changes. That is true of pretty much all marine ecosystems at fine scale. So as you move down through the water column, you find these distinct zones of marine organisms based on the amount of light that is available to them. A key example in temperate systems is where you have sunlight that diminishes to a point where you can no longer support algae and seagrass, and instead your seabed becomes dominated by animals, by invertebrates. But we also see very fine scale horizontal structuring of marine ecosystems. And there are some examples of that in the images below. So the central example here in the central image is of a rock that I photographed in northwest Wales. And on this rock, you can see on the surface of it, you can see the plants and the algae all growing. And underneath it, you find a species of soft coral that we have here in the UK called dead men's fingers. And they're growing on the underside of the rock, clinging to it. And the only way that they can do that is because there isn't sufficient light on the underside of that rock to allow them to allow the algae to grow and outcompete them. You wouldn't normally find this species in the intertidal, but this is a photograph from the intertidal. It's normally much, much deeper. And of course, it's there because of this kind of this cryptic habitat, this dark shaded area underneath this rock. And so what we tend to find is that light can shape marine ecosystems at fine scale and at broad scale, creating very, very complex assemblages of marine organisms. This horrendous diagram attempts to illustrate the importance of different components of light for biology in the sea. And the way that we think about this is we break the components of light down into four key areas. So the first one is the intensity of light. So that's how bright the light is. The second one is where that light is in the sky. So that's the position of the sun and the moon in the sky, which provide a compass for marine organisms to be able to navigate by. The third is the lunar and solar clock. So this is circadian rhythms and circulunar rhythms that many marine organisms exhibit. And they're using the moon and the sun as a reference point to attune their biological clocks to be able to do that. And then the final one is the color of light. So the color of light is very important for marine organisms to be able to see their environment, to camouflage in their environment, to recognize prey, to recognize conspecifics and make mate choices, and a whole variety of other important color-guided behaviors. And all of these various different components of light can be linked to a huge variety of these different biological processes in the central column. And those biological processes are absolutely critical for shaping a variety of higher level ecological interactions. So predator-prey interactions that then feed into population dynamics of increasing and decreasing prey and predator populations. Those then lead to a restructuring of ecological communities, and ultimately that can have an impact on the services which ecosystems provide to people. And so hopefully what this horrendous diagram does is it illustrates for you the fundamental importance of light in shaping marine ecosystems through its impact on a variety of different biological processes. Okay, so let's think about how nighttime lighting might be changing that natural light environment. So let's start with one key phrase. Think about it like this. Any biological adaptation that uses light is potentially impacted by the introduction of light pollution. Now, if we go back to that original figure where we were looking at that surface zone of the ocean, pretty much all the species that are inhabiting that zone, that epipelagic zone in the top 200 meters, are using natural light. They're using light from the sun or light from the moon in some way to guide some part of their life cycle. And that means that the introduction of artificial light at night has the potential to impact all of those species, and multiple behaviors being performed by each of those species. And it does this by brightening the nighttime environment, so it affects those biological processes that are driven by the intensity of light, by altering the cycles of sunlight and moonlight, so it changes the timing of important biological events such as reproductive events. It masks the position of the moon and the sun in the sky and thereby disorientates marine organisms so they can no longer use them as an effective compass. And it enables marine organisms to see colour at night, where previously they would only have been able to see colour during the daytime. And this is particularly problematic when it comes to LEDs. So the image on this slide depicts a variety of different impacts of light pollution in the sea, which were previously hypothesized back in 2014 and have since been proven to be true. So one of them, for example, is this one on the far right hand side where you can see these tiny little blue specks. These are an illustrative representation of copepods, a small invertebrate that lives out in the open ocean and migrates up to the surface waters during the nighttime to feed on phytoplankton and goes down during the daytime to hide from predators. And these copepods are extremely sensitive to light. They're so sensitive to light that in the polar Arctic regions, when there is no day-night cycle, they're actually performing these diel vertical migrations going up and down in response to moonlight. And they can detect that moonlight down to 50 and in some cases 100 meters depth. And what we found in the literature, it's been demonstrated by a colleague of mine, Jorgen Berg, in Norway, is that if you go to the polar Arctic during the polar winter and you shine lights from a boat, that those lights will suppress that diel vertical migration of those zooplankton. and it can have an impact on those zooplankton down to hundreds of meters of depth. So if you place that in the context of something like an oil rig, that can be a potentially huge impact. We've known for a long time about the impact of light on sea turtles and how it disorientates them in their seaward migration when they hatch. It also has an impact on where the adults choose to nest. Now, whether that's a behavioural response, so they won't nest near beaches, or it's a much longer term population demographic response. For example, the adults, the young that hatch on lit beaches don't tend to come back to those beaches because they don't survive the hatching process, is uncertain. We know that lights have been used by anglers and by fishermen for a very long time to attract fish in, and that is still very, very true. We know that it disorientates seabirds, and that results in mass seabird strikes on vessels in the Arctic and the Antarctic. And we now know that the disruption of the lunar clock by light pollution has an impact on the synchronization of the coral broadcast spawning response, which is absolutely critical for ensuring that corals have a healthy reproductive output. And what it does is it advances the timing of the release of gametes by about 2 to 3 days. And that creates a partitioning in time between coral ecosystems near to cities that are artificially lit and coral ecosystems that are in dark locations. That prevents genetic exchange, and it reduces the overall success of coral recruits as they were recruited into the ecosystem. So there's a huge variety of different biological impacts of light pollution that we know about now, and those are just a few key examples of the way in which we've demonstrated that it's impacting marine organisms. So let's think about the global distribution of light pollution. So one of the things that we've done is we've created this atlas, and you can access this atlas online. You can access it through the GoAlan website, or you can access it through the Aquaplan website as well. And this atlas is basically an atlas of the depth of biologically important light pollution into the sea. And we decide what biologically important light pollution is using that Calanus copepod that I talked about just now. So we set the minimum amount of light that Calanus copepod can respond to as the depth of biologically important light pollution, and then we model across the world how deep that light penetrates based on the Falke Sky Glow Atlas combined with our oceanographic remote sensing data products about the color of the oceans and how well light penetrates down through the oceans. And we get an atlas that looks like this. And around our part of the world in the North Sea and in the Northeast Atlantic, what we see is that coastal bounded light pollution is really, really profound. We find that there are huge swathes of coastline around the world, thousands of miles of contiguous coastline that are affected by light pollution. About 22% of the world's coastlines are impacted by light pollution in some form, and that's excluding the Antarctic continent. Around 2 million kilometres squared of the world's exclusive economic zones, these are the zones around our countries which we have a legal right in international law to exploit for economic purposes. Around 2 million kilometres squared of those zones are impacted by light pollution. There's been more than 200 published impacts of light pollution on marine species, but get this, there's almost no regulation of this in the sea whatsoever. And I'm sure that many of you are aware that you've been campaigning for a very long time to get better regulation of light pollution on land. Well, in the sea, there's practically nothing at all for most nations. And I'll go into that in a minute. The fact that there is no regulation of light in the sea led myself and my colleague that I work closely with, Dr. Tim Smythe at Plymouth Marine Laboratory, to come to the conclusion that we needed to set up an initiative that would try to drive forward policy that is designed to intervene and better manage light emissions into the sea. And so we established the Global Ocean Artificial Light at Night Network. This network is a network of the world's leading scientists that are working on this issue, and it's designed really to help improve knowledge and awareness of marine light pollution as a problem, but also to provide a body of expertise that can help in advising new policy and management and mitigation strategies to help reduce light pollution into the sea. The GoAlan network is now a UN Ocean Decade endorsed program, and we are mostly contributing to the first goal of UN Ocean Decade, which is to understand and beat marine light pollution in all of its forms. GoAlan emerged from a NERC project, the Artificial Light Impacts on Coastal Ecosystems, or ALICE project, that was funded here in the UK. And it was the first big international national consortium of institutions looking at marine light pollution as a focal issue. And since then, we've seen huge growth in interest in this subject and major research projects kicking off all over the world in places like Australia, across mainland Europe, in the Americas, and that has created a vibrant network of scientists that are working on this issue. More recently, we've had the Horizon funded Aquaplan project kick off, and this project is looking at the interaction between light pollution and noise pollution as two critical sensory disruptors of marine ecosystems and how they might be shaping the aquatic environment. We also partner up with the Darker Skies project, which is another EU funded project. And more recently, there is the JPI Oceans Changing Marine Lightscapes initiative. There are two projects funded under that. There's the Alanis project and the Isoloon project, which will both be kicking off in July. And they are looking at the combined impacts of light pollution, but also a more recent phenomena, ocean darkening, which is how the clarity of marine waters is changing such that light is actually penetrating less far through the marine ecosystem. And just to help you understand that a bit more in the context of artificial light at night, ocean darkening impacts the diurnal marine ecosystem mostly. So what it's doing is it's attenuating and scattering sunlight as it's passing down through the water column, causing daytime marine ecosystems to become dimmer. But then when you go to coastlines near developed areas, what you see is a brightening of the nighttime marine environment caused by the introduction of light pollution. And so these two things coupled are fundamentally changing marine lightscapes, and that can have big ramifications for the way that marine ecosystems are structured according to natural light regimes and how they function. There's a whole variety of different actions that we're involved in through the GoAlan initiative and the projects that are affiliated with it. So for one thing, one of the things I'm doing in my lab is I'm quantifying the criteria for good environmental status. And these criteria feed into the Marine Strategy Framework Directive, which is the key legislative tool within the European Union for managing pollution emissions into the sea. And under descriptor 11 is the introduction of energy, which includes noise pollution, light pollution, and electromagnetic radiation. But we haven't had specific criteria set for the good environmental status of light pollution because we just haven't had enough knowledge to be able to set them. But now we do, and so that's something that I'm working on in my lab at the moment. We're developing a variety of open access interactive mapping tools like the ones I just showed you. We're developing harmonized monitoring protocols for measuring light pollution and marine ecosystems. I'm sure many of you are aware that there are many, many different ways of measuring light, and it's really, really frustrating and annoying because you can measure sky glow using SQMs, or you can measure lux, or you can measure irradiance, depending on whether or not you're a lighting engineer, or you're a physicist, or you're an astronomer. There's a different instrument and a different quantity of light that you would measure. And so somebody who's new into this field will get really, really confused. And so we think it's really important that we develop harmonized protocols for measuring light. We're establishing a European network of monitoring sites for monitoring light pollution. I've got sites all the way around Plymouth Sound here in the UK, and we're visiting a number of sites further down in Cornwall, down in Falmouth as well, and they'll form part of a European-wide network. We produced the first global atlas of light pollution under the sea, which I showed you earlier. We're revising on a number of new policy instruments, which I will get into, but we're working with a number of different partners, including Blue Flag International, to try and develop a new policy that can help to mitigate the emissions of light into the sea. We've built an international policy database. We're establishing new partnerships with government and industry, and we're constantly providing guidance on sustainable lighting practices. And we've recently finished developing risk maps for ALAN at a European scale, which will help policymakers understand better which areas are really highly impacted by light pollution and which areas are less impacted by light pollution. Because policymakers, they don't like units like irradiance because they don't make any sense, but they do like squares that are red or amber or green because they do make sense. And so we've made one of those maps of red, amber, and green because that's the sort of thing that policymakers can get their teeth into. Excuse my spaniels, they're going mental downstairs. So, through the Go Alan initiative, we've been interacting with a huge number of different organisations. But some of these reports, which came out since 2023, just really highlight how firmly this is now on the international policy agenda. So these reports are coming out for a variety of different organisations, from the Great Barrier Reef Authority to the Australian government, the IUCN. There's a future brief here from the European Union, and what they basically illustrate is that light pollution is very firmly on the agenda, and not just light pollution on land, but light pollution in the sea in terms of its management. And we've been working with all these various different organizations to try and have an influence on policy when it comes to light emissions into the sea. Okay, so within UN Ocean Decade, which is a very, very big initiative with lots of programs and lots of projects, we're trying to interact as much as we possibly can with some of the other projects to improve the translation of our knowledge into guidance and policy interventions, but also to support small island developing states in developing environmentally sustainable lighting. Because one of the key areas that we see a lot of focus on tourism and tourist development in their economies, and not a lot of consideration being given to how those coastal developments are impacting the key ecosystems that are attracting tourists in further offshore. And there are some areas of the world that do this very well, and there are other areas that aren't doing this very well. So one of the things that we've been trying to do recently is to work with Dark Sky International on the concept of a marine dark sky park. We think that a marine dark sky park could be a really useful way of capturing the need for small island developing states, and also developed states as well, to better manage light pollution emissions into the sea by giving them a really key badge, something that they can sell to potential visitors and boost their tourism income. Okay, so in terms of the key policy objectives at home, we've got some really big deficits that we're trying to deal with. So one of the problems that we had in Europe was that when the Marine Strategy Framework Directive was formed, and Descriptor 11 was written, there was not much known about light pollution. And so what happened was the legislators started writing more and more about noise pollution. And then when the Marine Strategy Framework Directive was translated into the national legislatures, light pollution was completely missed off the agenda. So in most of the national instruments that implement the MSFD, there is no mention of light pollution, and that includes our one here in the UK, the UK Marine Strategy. So the UK Marine Strategy interpreted Descriptor 11 as being primarily about noise pollution, and light isn't mentioned anywhere in the UK Marine Strategy. So we need to get that changed here. We need to get that changed, and we need to include light pollution. We also need to get the UK government and the EU to commit to some criteria for setting good environmental status of light pollution in European waters. We are developing those at the moment in my lab, and hopefully within 3 to 5 years we can see those translate through into policy. And then the member states will be forced to then take action in terms of reducing light pollution to try and achieve those criteria of good environmental status. We want to make consideration of light pollution impacts mandatory for applications managed through the Marine Management Organisation here in the UK. And that's the organisation that's primarily responsible for offshore development. So what we see in our onshore planning legislation is there is a requirement to consider the impacts of light pollution on nature. But that requirement isn't specific about marine ecosystems either onshore. So we need that requirement to be specific about marine ecosystems onshore. And we also need the Marine Management Organisation to make it a statutory requirement to consider the ecological impacts of light pollution and marine ecosystems offshore. And this is very, very important right now, because what we're seeing, especially in our part of the world, is a very rapid expansion of offshore infrastructure, particularly in the wind turbine industry, but also offshore oil and gas is not going to die. They're refusing to die, and they've decided that they are going to move into green hydrogen, which means even more offshore infrastructure. And so it would be good if we could get them to consider the impacts of light pollution and how they might reduce them when they're building new rigs offshore. We've been trying to push that agenda here in the UK as much as we possibly can. And we've been doing that by having direct interactions with the UK Parliament to try and get them to adopt some of these policy changes into law. That is a very, very slow road, unfortunately. As you might have experienced yourselves, changing legislation is particularly difficult because you need to get a huge body of stakeholders on board to be able to do that. And right now, we're at a point where we're just starting to get a murmur of a conversation about this, a number of politicians interested in it. We're increasingly talking to Parliament about it, but trying to get change is challenging. So hopefully, again, in the next 3 to 5 years, we'll see some real change. Right, that's going to be all from me. I'm going to take some questions, but before I do, I am going to mute myself whilst I deal with my dogs.
Great. Thank you so much, Dr. Thomas Davies. What an incredible presentation. And I was really enthralled with a lot of the things that you were saying. Let me pull up my notes here. I love the quote, any biological adaptation that uses light can be impacted by light pollution. I think that was a lovely, clear way of, saying that this light impacts basically everything. So we need to pay attention to it. If you need to go let your dogs out, that's okay. Did you get them already?
They don't need letting out. They just
Okay.
need to be quiet.
I think they need to be brought on to the meeting. I think that's what they want to
No,
be seen.
no. Bailey is a really bad Zoom bomber. He will just trash the whole call.
Yeah, dog tax, says Chris. We'd love to see the dogs. But anyway, yeah, thank you so much, Tom. That was a really, really good presentation. I want to hear more from you, honestly. Like, I feel like this was just a little taste. I would love like a whole seminar about this because this is something that is new to me in terms of understanding impacts of light on the environment. We all know about the turtles, right? But a lot of this that you've been talking about is really new information to me. And I've been at this, dark sky movement for, 10 years now. So I think we need a lot more of this education. And I really thank you for your time and bringing this to the forefront of our awareness. Um, so I would just like to ask a question kind of for everybody here, I think, is like, how can we as dark sky advocates, not in Europe, right? And I'm landlocked in Utah, like, how can we support your work and this global work of better lighting for our world's marine environment?
I mean, are you speaking as a kind of as individuals or as an organization?
I think as individuals, like, I mean, and for people tuning in, right, we have chapter leaders, we have individual advocates, we have people from all different parts of the world. Yeah, what are ways, like, can we share your atlas? Are there, is there any specific actions or support that we can do that we can call on this international community that we have here today?
Yeah, I think promoting all the tools that we've developed and trying to circulate them and trying to raise awareness is certainly one way of doing things. The problem that we have when it comes to policy, and I'm sure this is something that you're familiar with on land as well, is when you're trying to get people to change lighting practice, it's very difficult. In Western culture, we have this very deeply ingrained idea of light as being good and dark as being bad. And so there is an almost inherent fear of the dark, which is difficult to tackle. You know, just a quote from a conference that I went to many, many years ago. There was somebody there who was talking about how light pollution, well, introducing street lighting didn't reduce crime levels. So they couldn't understand why city suburbs would have street lights on at night and cite crime as a reason for it. And one of the members' answers to this was they turned around and they said, "Well, it doesn't matter if my daughter isn't actually at risk of increased crime at night. What matters is that she feels safer."
Absolutely. Yeah.
And that's a very, very, very hard argument to come up
Yeah.
against, right? Um, so I think what this boils down to for me is what makes us feel safe. And if we can start to have conversations about the importance of darkness and what makes us feel safe and what doesn't make us feel safe, we might be able to change popular perceptions of dark and therefore the need for artificial light at night. And certainly there are some countries in the world that do this very well. For example, Japan embraces darkness. If you go to the streets of Berlin, the streetlights are incredibly dim. And I was told by some Berliners that that's a hangover from the war because they didn't like to brightly light their streetlights because it would attract the bombers or something.
Mm.
So there are very, very different cultural narratives and experiences of light and dark. And I think that is a key way. We've got to get down to the root cause of the problem. The root cause of the problem is people's attitude towards darkness. And I think if we can address that, then we can start to make real policy progress because policymakers will then be less afraid to introduce legislation which tackles the issue.
Yes. Well, I totally agree. So, all right, you guys, we just have to do an entire cultural consciousness shift around darkness. But that is what we've been trying to do with Dark Sky, I feel like is, yeah, both help people understand the benefits of darkness, but also the incredible power of light, and how impactful light can be. So I really appreciate that, that viewpoint, Tom. All right, let's see some other questions here. Um, I like this question from Anne. Is this work being communicated to aquariums around the world so they can help educate the public?
Um, the short answer to that is no. And it probably should be. We do have a lot of interaction with the National Marine Aquarium here in the UK because it's just down the road from where I work. Um, but it's not something which aquariums have jumped on, and it's not a point where we've actually reached out. One of the pieces of work that I've tried to do with aquariums, I've tried to get aquariums to think more cleverly about how they are lighting in aquariums. Because one of the things about aquarium lighting, in what we call controlled environment lighting, is it's not very naturalized at all. So you tend to find that the lighting control system in an aquarium tank might be, well, the janitor turns the lights off before they leave for work, you know, or they're on a 12-hour light dark cycle. And they don't track the seasons. They don't have a dawn and dusk. They don't have a moon. They don't have any of the natural components of a natural light cycle. You think about that, you think about, okay, so, what does solitary confinement look like for a person? Well, it looks like being locked in a cell with no natural light cycle, you know? And what does that do to a person's sense of time? You know, sanity in human psychology is measured in three dimensions. It's measured by our ability to orientate ourselves in time, our ability to orientate ourselves in space, and our ability to orientate ourselves in our communities. And so the introduction of light pollution removes two of those things: the ability of an organism to orientate itself in time and space. And that is absolutely critical. So that's the area where I think I've tried to make more traction with zoos and aquariums, is in improving the lighting systems so that the organisms that are inhabiting there are exposed to more naturalized lighting regimes.
Mm. I love that, but I think maybe the question also is asking like using these aquariums as an educational tool so that the people in the aquarium can speak about how important light is to marine environments. Have you had any positive response around that or use of aquariums as educational tools?
No, I mean the aquariums generally haven't picked up on the issue.
Hmm.
And so we haven't had much traction there. It's not something that I've had time to push personally. But if I do, if I was to be approached, then it would be something I'd be very keen to work on.
Yeah, yeah, I love that. And now thinking about these fish in lit environments for 24 hours as being in solitary confinement. Well, at least they have their little community of fish, at least it's not all three aspects.
Yeah, they can all be sad together.
Yeah, misery loves company. I like this question from Stephen as well. We've talked a lot today about the impact of light pollution on, ocean and seasides. Is this similar to like lakes, rivers, and streams?
Yeah, the processes are very similar. So actually, the first documented scientific evidence of the impacts of light pollution on zooplankton came from a freshwater lake system. And we've been studying impacts of light pollution in rivers and lakes for a lot longer than we have in marine ecosystems. There's also what we call riparian ecosystems, which is the kind of interface between the land and freshwater systems, which have been studied for a long time by colleagues like Liz Perkin over in the US and Franz Holker in Germany. So we've known about those impacts for quite some time, and the processes are very similar. So it affects zooplankton in the same way, it affects fish movement and migrations in the same way, but the interesting difference is that when you think about a marine ecosystem, you're thinking about a largely three-dimensional seascape. When you're dealing with a riverine system, you're dealing with a much more one-dimensional structure. It's like a road.
Mm.
And the interesting thing about that is when you're putting lights either side of that, you're creating barriers, you're creating pinch points. So what you see when you look at the literature is you see examples of, for example, you might have some bridge lighting that's installed, and then you see seals gathering around the bridge lighting, hammering the salmon as they're undergoing their migration because they've worked out that they can predate the salmon more easily underneath those bridge lights, and it's the kind of marine equivalent of the bats and the moths. So your nocturnal aerial invertebrates are attracted to your street lights, and then here in the UK, our pipistrelle bats then basically fly down rows of street lights and they pick them off, bang, 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 bang. And it's that vacuum cleaner effect, and you get the same vacuum cleaner effect in the marine ecosystem. You get it with bridge lighting, but you also get it with pontoon lighting, marina lighting, those types of things as well. And you're quite often, if you're dining down by a marina at night and you can see into the water, you might see some decorative lighting on the pontoons, on the bollards or something, shining into the water, and you will see fish swimming around, picking off invertebrates that are landing on the surface of the water. There's some work that was done in Australia a while back, and it actually showed that if you illuminate hard surfaces at night in the built marine environment, that the fish then come and predate on the invertebrates that are living on those hard surfaces much more intensely at night, and it causes a fundamental change in the actual makeup of the invertebrates that can then survive on those hard surfaces. So it's really fundamentally restructuring the built marine environment when you introduce lighting.
Yeah, and I'm just going a little off script here, but I'm just thinking of like times that I have been at an ocean and I've seen these huge squid boats. Like I'm pretty sure there's this squid boats, and I've seen images from our chapter in Taiwan that like the sky is basically green. There's so much light from like this particular style of fishing. I'm not sure, maybe if I thought it was squid, I'm not sure exactly what it was, but like can you talk a little bit like about how large that problem is and if there's any sort of like compromise or possibility to like have that type of commerce and like fishing practice along with sustainability in our oceans?
Yeah, so I mean, light fisheries, the biggest light fishery is squid fishing, as you've identified. It's particularly popular in parts of Asia. And if you look at satellite images, you can see that the cumulative footprint over a year of squid fisheries is, in excess of the artificial lighting that comes from the entire city of Seoul or the whole of South Korea. It's huge. It's a massive, expansive footprint. Now, obviously, that fishery has a damaging impact on squid because you take the squid out and you eat them. That's not good for squid, right? The impacts on the surrounding marine ecosystem of shining lots of lights into the sea in that way are currently unknown. Um, but there is a flip side to this, which is there's also an emerging field in light fisheries of using lights in innovative ways to try and reduce the damaging impacts of bottom trawling. So I don't know how many of you have picked up on David Attenborough's latest documentary, but it's David Attenborough, he's his kind of swan song, I think it is. He showed a clip of the damage caused by bottom trawling to seabed ecosystems. And one of the things that we've seen here in the UK is a number of developing initiatives which are using very small LEDs in pots to attract in species that would normally be fished for using damaging bottom trawling. And this has become affectionately known popularly among the UK marine community as disco scallops. So it's these lights that you put in a pot, and the scallops then sort of flap their way into the pot, and then you bring the pot up. Um, so one of the things I want to be careful to do is distinguish between potentially damaging light fisheries like the squid fishing on a very large mass industrial scale, and the capability of using lights in innovative, controlled ways to try and reduce the impacts of bottom fishing in marine ecosystems. And then quite often we find in conservation that we've got to make a trade-off. I'd rather that there was no being light put into the sea at all. But if the introduction of small LEDs is offset massively by the gains of reduced bottom trawling, then I'm all for that, if that makes sense.
Yeah, that's very cool. And I had no idea that that light was equivalent to the amount of light in Seoul. Like that, that really puts that into perspective of how how much light is coming from this practice.
Yeah, there are satellite images from Suomi MPP that would blow your mind.
Wow, can we find those on the Go Allen website?
Uh, Not on the Go Around website, I don't think. But I can forward an image to you.
Great. Yeah, we would love to see that. And I have a question here from Leanne who asks, how can science writers best pitch your concerns to the general public? Giving examples of the unfortunate effects of excess light underwater isn't something they can directly relate to because they don't live in the water. Yeah,
Yeah, it's a good question. It's really, really hard. One of the problems that we have is that if you are an observer stood on the shore at night looking out to sea and you're stood in the middle of a big city, all you can see is dark. The sea is dark as far as you're concerned. And it's the same effect that you get if you're sat in your lounge at night time looking out of the window, and the lights are on inside. You can't see the outside environment because your eyes are adjusted to the brightness of the inside environment. So you won't necessarily appreciate how well lit the outside environment is. And that creates a problem because most people live on land. And so the perception is that there's no light pollution at sea. And it's been difficult. It was difficult at first just to convince scientists that there was light pollution at sea. Then it's difficult to convince policymakers and it's difficult to convince the public. So how do you tell that story in a way that captures the public's imagination? And I think the way to tell it is if you can tell it from the perspective of an organism that inhabits that environment. If you can tell it in that way, then people might be able to understand. One of the ways in which I talk about light pollution is I often talk about how their lives are affected by artificial light at night. You think about what do you do with artificial light that you wouldn't be able to do without artificial light? Well, you eat later, you go out on the town, you socialize, you go looking for potential mates. You do all these kinds of activities that marine species are also able to do in the presence of artificial light at night. And so if you think about it in those terms, it better captures the public's imagination, enables them to say, oh, okay. So it is a really big thing that actually, if it's changing the way that I live my life, it's probably changing the way that they live theirs as well.
Yeah, I love that. Put yourself in their shoes or their fins. Um, I have a question here. Let's see. That, we have heard of ports and like fisheries adopting dark sky principles. And I was wondering if you have encountered kind of any great examples of conservation with these groups.
Um, the ports the ports example is an interesting one that's developing. So this Darker Sky project in the EU is working with lots of port authorities on trying to identify mitigation measures which would be acceptable. We've also on the Aquaplan project just completed a survey of potential stakeholder groups in maritime industries to try and establish what can and can't be done. Um, it is always going to be limited, and it's going to be limited mostly on health and safety grounds. Most ports and harbours 24 hours, and that means that they need to have lighting for safety reasons. If somebody falls into the sea, you need to be able to find them, and so that creates difficulties. One of the great examples that I can point to, though, is actually in shipping down in the Antarctic. So, as we know, for a very long time, ships in the Arctic using their big searchlights to look for icebergs have been suffering from mass bird strikes. These are seabirds which are undergoing migrations. They become disorientated in bad weather conditions. They're attracted by the lights and they fly straight into the side of the ship. And it can result in mass mortality events where you have thousands of birds that are killed in a single event lying on the deck of a ship.
Wow.
British Antarctic Survey didn't like this. They didn't think it was a very nice thing to be doing. So they introduced a number of protocols to try and help reduce bird strikes. And this included things like turning off deck lighting and making sure no people are on deck at certain times of night when the deck wasn't in operation, managing porthole lighting, changing the colours of lighting where they could do so to try and really help to minimize those effects. And it just goes to show that you can operate a ship offshore in an ecologically sensitive way. You can't just hide behind, well, we need to have the lights for health and safety.
Yeah. Yeah, agreed. I like to think of it as like fully sustainable lighting, because there's lighting that's energy efficient and it's sustainable, but you have to consider those broader impacts for it to actually be fully sustainable
Yeah.
lighting. So, I have a question here from Todd, who is from Minnesota, and says, in Minnesota and the greater Midwest, invasive zebra mussels have vacuumed up the suspended matter in our lakes, increasing clarity and allowing light to penetrate deeper into the water column. Are similar things happening in marine ecosystems?
What we tend to see is we tend to see something slightly to the inverse of that. So when you look at our atlas of the depth of biologically important light pollution, when you move very close to the coast, you see that actually the depth of biologically important light pollution reduces as you get closer to a city. And the reason for that is as you're moving closer to the coast, you're getting more disturbance from wave action, more sediment being stirred up. You've got more stuff being washed down from rivers that's stimulating phytoplankton growth. And that's causing the ocean to become less clear in terms of its optical properties. So light can't transmit as well through it. So you tend to find that actually you do have there's light pollution there, but you tend to find that actually you get a slight increase in light pollution as you move a couple of kilometers offshore before it tails off. So it's a bit of a controversial thing because one of the other areas that I'm working on at the moment is this ocean darkening phenomenon. And a key kind of solution to ocean darkening is this kind of zebra mussel example, although using a native species rather than a non-native. Um, like for example, here in the UK, the North Sea used to be populated with oyster beds, native oyster beds all over, and they would basically act as a giant filtration system, filtering the water and keeping it clear. Now that's great because we want clearer water, because clearer water is better water for our marine organisms to be able to perform their daily lives in. But we also then need to, if we're doing that, we need to reduce the amount of light at night because as those waters clear, the depth of impact of that light is then increasing. So the mitigation of those two things needs to be done in tandem.
Yeah. Very interesting. I have never heard of ocean darkening before. And from our side, darkening sounds good, right? But yeah, not always a good thing. So we have a couple questions here from Eileen. She asks, does the military consider any of this in their bases? Do you have any awareness of that?
I mean, Plymouth is home to the largest naval dockyard in Europe. Um, and we have real difficulty getting traction with them. Real difficulty. Um, they are very, very sensitive. They are very, very security aware. Just to give you an example, I recently tried to put some hydrophones out in Plymouth Sound to record noise pollution, and I was told I wasn't allowed to because there were Type 3 security clearance vessels that were passing through Plymouth Sound. Apparently, you're not allowed to record the sound of a nuclear submarine. Anyway, um, so yeah, we struggle to get traction on that front, but I I understand why, and you know they they possess some of the most sensitive security assets in the country,
Yeah.
and they need to keep them secure. And that means adequate lighting. So turning around and saying, "Oh, you need to dim down that lighting or not use it at certain times of night because the nature might be affected," it just doesn't cut it with them.
Yeah.
And
Well, you would think they wouldn't want all their stuff lit up for people to see. That would be my
oh,
thought.
it's that old chestnut, isn't it? Of well, if you light a place up, then people won't go there because they're afraid of being seen doing something bad. Actually, that might be true on a military installation because it's much easier to shoot someone if they're well lit up. But one of the things that we see here in the UK is actually when you turn the lights off, say in a suburban park, the teenagers stop going there because they can't see what they're doing, so they go somewhere else, like a car park that's well lit.
Yeah, absolutely. Well, so you mentioned noise pollution. Leanne asked a question about noise pollution, kind of why do you think noise pollution was considered and light pollution not mentioned? Do you can you speak to maybe the intersection of noise and light pollution within the marine environment?
So what's interesting is that these are two forms of sensory disturbance. So for many, many decades, we've considered impacts on the marine environment in terms of the quality of the water. So that's the amount of stuff, the amount of pollutants that are in it, how clear it is, the amount of sewage going into it, the amount of oil going into it, the plastics going into it, all the stuff that we're putting into the sea. And then we've considered it in terms of stuff that we're taking out of the sea. So all the damage that we're doing to it, the fish that we're taking out of it, all that kind of stuff. What we've not really thought about in a great level of detail is how we're changing the sensory environment of the sea. And let's think about that in the context of the way that we live our lives. So, if, for example, you were to move into a flat and there's a really bright street light outside and it's keeping you awake all night, that's affecting your quality of sleep. That's affecting your quality of life. If you're on a short-term tenancy and you can't convince the local authority to turn that street light off, are you going to stay there? Are you going to think about moving somewhere else? And so, marine organisms might do the same thing. They might not like to stay there. And so, what we have is a situation where we have two forms of sensory pollution. And what they do is they create a lot of noise that prevents marine organisms from going about their day to day lives. That means that marine organisms have got a choice. They can either go about their lives in a less efficient way, or they can move somewhere that's quieter, somewhere that's darker.
Yeah. I would move somewhere quieter and darker myself. I think most of us would. Well, Tom, thank you so much for your time today. I know you have a hard stop, and I really want to respect your time, but I do want to just share so much gratitude for sharing all of this incredible information with us. We would love to stay in touch with you and continue to support your work. I know Ruskin is involved with I saw him on the Go Island website. So in your Dark Sky logo. So we're really glad to be partnering with you. And anything that we can do, the Dark Sky Advocate Network can do to support you. We have a huge group of people here ready to help protect the marine environment. So call on us if you ever need anything. And yes, thank you so much for your time.
No worries, guys. It's been an absolute pleasure. I'm so pleased that you've invited me on. I'm very, very sorry about Kai and Bailey. They're very rude dogs. Um, I would say I would punish them, but I don't have it in me to do that.
No, please don't. All right. Well, thank you. Enjoy your evening. Good luck with your remodeling, and we'll talk soon. Thank you.
Okay.